All right, I think we are good to go here. So again, hello everyone. Thank you for joining today. My name's Alex Vasquez with Expert Hats. And as we've been talking a couple of different items here, covering a couple of different technologies, really in this intro series, the aim for this next topic is helping you understand what is virtualization and how it's really impacted the IT industry and has been influential, especially over the past 22 years. Yes, I remember back in 2002 and obviously, even prior to that, well, that's really when you started seeing this vestiges of a new technology and new company coming to play called VMware. And then after that, many other partners coming into play. And we'll be talking about that here. But it basically changed how IT operates, functions, how it's able to manage multiple droves of computer systems and server operating systems in a way that is more manageable, flexible, and has really made it really significantly easier to be able to keep things up and running and maintained and increase high availability across the board. One of the, in my previous videos, one of the things I mentioned is that, especially with server operating systems, they tended to be one-on-one, and, they tended to be built in such a way where you always had one piece of an application or one application to one operating system, right? And that one operating system had to live on one piece of hardware. So when that practice as an IT, it didn't go away, it continued. And actually that's what inspired the movement towards virtualization, allowing us to now be able to introduce new flexibility in that common practice as well of a single operating system, a single piece of hardware, a single piece of an application, whether it's one application or a part of a much larger application playing a role of that application. So, virtualization enables a lot of that while now introducing the capability of being able to share the hardware level while still maintaining the protections and the flexibility and the maintenance aspect that was an IT practice and has continued even to this day. So we're going to be diving deep into this topic. Let's get started. So as we start looking at virtualization, what are we going to be focusing on today? Well, we're going to talk about how it started. I already kind of gave you a preview of it. Why is it needed? How does it work? And who are the major players? And really, where is the industry continuing to head in this regards? As we start looking at what is virtualization, I want you to understand that this is a broad term nowadays, especially. There's platform virtualization, which a lot of times that's when we start talking about the hardware, and that's what we'll be aiming towards heavily during this conversation. But there's other forms of virtualization that has happened, and all with the goal of removing the limitations of one-to-one. Application virtualization, meaning I can install the application once, and then as a file or container, simply be able to move it to other operating systems and other servers or other desktops and not have to reinstall the application again. I mean, that's very powerful. Then there's storage virtualization, network virtualization, and so on and so forth. The industry has continued to amplify and to break up the components that make up a server operating system or a network into different capabilities that are now software defined, for example. But that's a topic for another day. And then today, what we're going to be focusing on heavily is that platform virtualization. This is where we're going to really understand the basis of virtualization and how it provides an abstraction layer, a layer between that hardware, the physical hardware, and the operating system within it, and actually kind of sits in the middle between those two, allowing us to then decouple basically the operating system from the physical hardware, introducing a new layer. And again, it's continued to be an industry game changer all across the board, especially between 2002 and 2012. It was heavy, and it continues to transform and change over time. So we have to understand again, what problem was it trying to solve? Well, it wasn't uncommon to see rows and rows of data center cabinets with these, what we would in the industry call pizza box servers, right? And it's these physical servers that were really small because, applications didn't require a lot of hardware in regards to capacity. They didn't require a lot of CPU or RAM or storage. However, as an industry practice, it was very common for it to be a one-to-one-to-one, and as such, that the term pizza box servers came into practice. And the idea there was it was commodity, right? A single application would probably require 5 or 6 of these pizza box servers that were all hardware and operating system and everything else. And the net effect of that is that every time you turned on one of these pizza box servers, they were power hungry. They got hot, so they required more cooling, and so they required space, and so they required more and more capacity physically, and so data centers were larger, they were hotter, and all to run applications that really sometimes didn't need all that hardware. So it was just the practice that was needed. And so this is a change in that virtualization was aiming to solve for. And because this is still a common practice today to have an application to an operating system to a piece of hardware. Now that's where the hardware part comes into play, where virtualization starts to come in and change what the definition of hardware is. And so you might hear this acronym, an OSE, or an operating system environment. You'll see that through the slides. Just know that it's that whole bubble, I would say, of the physical hardware, CPU, memory, the networking, the storage, all within a operating inside, that would be one container, and then you'd have the next level of operating system, and then the applications all running within that particular layer. Now, like I mentioned, single operating system, software and hardware were really coupled together. Underutilized resources was common, and inflexible and costly infrastructure, especially when you take into account that some of those pizza box servers, would easily run $5,000 to $20,000, especially during that time frame where a lot of this hardware was being purchased. So when virtualization came into play, it really did start changing the game, because now what virtualization allowed you to do is to still have separate operating system environments with its own applications and everything inside of it. But now you would create what's known as a virtual machine. And really this is where the magic really took place, because what especially the early virtualization platforms did is they simply created a software-based hardware environment. Right? They defined via software what hardware was. What is a CPU? What is a network adapter? What is a storage adapter? What is, memory? And then be able to create a sandbox, so to speak, around that operating system environment and present generic versions of hardware that then could be, run on a platform that could be, you can now move it independently of others. And now you can have multiple operating system environments, multiple virtual machines. And that could be, and that's regardless of the hardware. So you end up having more portability as a result of it. And by being able to do this, it now introduced new concepts of being able to even simplify management of all these VMs and these operating systems by encapsulating them within virtual machines, because each virtual machine is instance when it's shut down are simply a set of files. Files that you can put on a USB drive, files that you can transfer over the internet, files that you can copy from one computer to another, files that can be stored in a common place and then accessed by multiple computers. The possibilities started becoming really apparent and really vast, especially when it came to the flexibility that was needed. And so, when we started looking at virtualization, there were a couple different ways in which to introduce virtualization to the market. Initially, you can actually install a piece of software such as VMware Workstation, which I have a video that I walk you through on the latest version of Workstation to install on your computer, and be able to stand up a couple of virtual machines yourself. A link will be available at the end of this session. But then also, being able to run this on your Windows 11 or your Windows Server or operating system or anything else, because it's just an application itself. And then within the application, it would then allow you to run virtual machines as well within that. So, you start getting into these almost like Russian doll scenarios, right? Where, you have smaller virtual machines within other virtual machines, all the way down to the largest, which is the physical. Thinking of it backwards, you have all these layers. And so that's really where a lot of the benefits came from. Now, this worked for a time, but what it was still doing is it was still competing for resources with that host operating system. And so what started happening is that, vendors like Microsoft, vendors like Nutanix, vendors like VMware, they started changing and introducing a new layer of virtualization. And that was one layer deeper. So instead of a hypervisor or virtualization application running on top of an operating system, it became the operating system. And so you started really simplifying and stripping out all the unnecessary components of an operating system in order to really refine and minimize the amount of resources that were needed to run that level and make all of the rest of the capacity and features available to all the other operating systems as well. And indeed, a lot of times what ends up happening is that the interface that you typically would log into is in and of itself a virtualized layer. So the hypervisor actually runs one level deeper than what you're interfacing with on that virtual machine. It's a little bit different, interesting concept to grasp, but don't worry, you don't have to really focus on that, especially nowadays. But just keep in mind that a lot of times when you're accessing a GUI, or a terminal on a hypervised and bare metal operating system for virtualization, that interface itself is in a sandbox. And so it is managed and controlled just like any other virtual machine that is sitting and running on that operating system. So what does this do? It helps then share all of these resources with the different virtual machines that are on there. So what does that mean? Well, that means they could share the same CPUs, the same processors, the same RAM, right? And it allows now for much bigger hardware, much more RAM to be actually packed into a server. And now it can actually take advantage of it. Because oftentimes with those pizza boxes, what started happening is that those machines and those applications didn't require as many resources. So, or companies didn't buy massive servers for a 1-to-1 ratio. They would just buy tiny servers or as small as they possibly can in regards to specs. Now with virtualization, they flipped it because now they could share that hardware amongst multiple operating systems, multiple VMs. And so now they were buying servers that were packed with memory and storage and processors, and it actually created this new hardware boom as a result of it. And that's what we still see today with many of the servers, whether it's running in a data center or in a cloud environment, is that overcapacity, that hunger for much more capacity than oftentimes a single application would need. From there, we mentioned about the different levels. And that's really the key here, because the hardware was being virtualized as well as the BIOS was being virtualized. And then once from a software application, these things could be virtualized, then adding an operating system and application on it was a no-brainer. I mean, it just simplified things quite a bit. And this is where it really allows us to the capabilities of being able to make these virtual machines transportable between hardware. And nowadays be able to move a virtual machine with everything that's installed on it and everything else, even to a different data center in a different region, different country, and a different cloud provider or a different data center. I mean, just the capabilities are pretty vast from this perspective. And then from there, what they did is, when you start looking at the parent and the bare metal, they put that hypervisor level there. So instead of in this scenario where you have, let me go back. So instead of this scenario where it's hardware and then the BIOS and then the operating system and then the application, this is where it started changing. So it would then went to hardware, BIOS, the hypervisor, which is the bare metal, and then the parent partition, which is what you would modify, and that's a virtual machine in and of itself, or treat it as one because it's sandbox, even though it's depending on the architecture, it looks like it and sometimes it doesn't. But it runs basically in the same space as virtual machines and acts that way as well. So what this now allowed you to do is really be able to break it up. Again, a single hypervisor on a single piece of physical hardware now allows you to have multiple VMs, and within each virtual machine, you see the different layers: hardware, a BIOS, an operating system environment, and the applications on top of it. And then they communicate each other over a network. And that network typically is a virtualized network, and where it's then connected to physical networks through a network interface card on that particular server. So, lots of different options here from that standpoint. Now, what were the immediate benefits as a result of it? Well, the first thing that really happened was this movement towards consolidation. Less physical servers, no more small servers. That's then lowered power requirements for entire data centers, as well as when you're lowering power, you have less heat. And so now you're dealing with lowering cooling requirements in HVAC. Now that hasn't gone away, but it has changed the equation, because now, even though we went with less physical servers, nowadays we're talking about density. And density started to, it basically shrunk everything. You had all these hardware, it shrunk all the way down. And then now is about, okay, we need more servers and more servers. And so that started growing in data centers. But the amount of servers that could sit in a single data center today versus what it used to be is almost, I want to say easily 100-fold at least, right? Just the way a lot of virtualization capabilities and how everything's structured today. So, it's a completely different way of managing, but it has created the capability for like a lot of these cloud organizations to now be able to extend and build upon that concept of virtualization and really move on to the next piece. It also really started changing the thought process around what is hardware resources. So instead of thinking, oh, this server has 16 gigs of RAM, that server has 16 gigs of RAM, because I can move virtual machines between hosts, now I'm thinking about pool capacity. So if I have 3 servers with 16 gigs of RAM, now all of a sudden I'm thinking, oh, I have 48 gigs of RAM that I can run virtual machines with. And now and every time I add a physical node, it's increasing my capacity pool as a result. Same thing with, CPUs and storage. And storage has changed over the years in regards to how it's managed and so forth. And we won't get too much into that, but it's really transformed and allowed us to be able to really pull virtual machines and stretch them across numerous hardware platforms and servers, and hypervisor environments and cabinets and you name it. I mean, I could keep going from that standpoint. The other thing is that, with larger servers, again, instead of, smaller servers kind of go away, everything started transitioning again to larger, right? More RAM, more CPU cores. And nowadays, I mean, it's easy to get even servers with almost near hundreds of cores, all with multiple processors and things like that. So it's really growing from that perspective and continues to be a transformative process as well. Now with each virtual machine, now because it's more of a file and a virtualized hardware, what ended up happening is administrators in a lot of these platforms, they started gaining more control as far as what you can do with that virtual machine. And this included things like checkpoints or snapshots. The terminology changes depending on which virtualization provider you're using. But the idea here is, okay, if I have a virtual machine and it's a file, can I just take a point in time picture of it, make a change, and if the change doesn't work, go backwards? Okay, that's a snapshot, right? And then you can remove the snapshot so that it doesn't take up more space. And now you have a copy that you can go back to and you can remove if you need to. That also allows mobility because, virtual machines are files. So you can copy them to another server, whether that is copying it while it's turned off, or more commonly nowadays is copying it and moving it while it's turned on. And that's provided by different technologies. And every virtualization platform calls it a little bit differently, but it makes it very mobile from that perspective. Additionally, high availability is amplified now with virtual machines. So being able to quickly, if a piece of hardware goes down now with hundreds of virtual machines on it running, if it goes down physically because something happened to it on the hardware, it can easily be brought up quickly on other devices because of storage capabilities and internet networking and pooled capacity. So being able to quickly bring that up, and hundreds of virtual machines up, very quickly, I'm talking about a matter of minutes, it's very powerful. And so that's another feature that was introduced. The other thing is a disaster recovery. Now, the difference oftentimes between high availability and disaster recovery is that high availability is about making sure an application stays up or a server stays up within a certain time window within the same building, is how I would best describe it in simplest terms. Disaster recovery is making sure that all those applications, all those virtual machines can be brought up in a completely different building in a different city within, let's say, an hour. So, that's disaster recovery. It's being able to still replicate and copy virtual machines on a continuous basis so that you can minimize how much downtime of an application in the case of a disaster, whether that is a natural disaster or a man-made disaster. Now, again, this example here is using Hyper-V, but virtual machine or VMware and Nutanix have very simple concepts in this regard, or very similar concepts rather. And so it's a point-in-time copy of a virtual machine. It doesn't affect the running state of a virtual machine. It snapshots any guest operating system, and the VM can be running, off, or not, right? And again, just really highlighting that these things are files, right? There's usually some kind of extension for the file system that's created. Now, when you're creating checkpoints and snapshots, there are some best practices around this. In a production environment, you want to use snapshots or checkpoints for very long. They're very purpose built that way. where you want to make sure that, because changes in a snapshot or a checkpoint get captured independently of the original files, you want to make sure you kind of condense them as such. So it's best practice just to keep those in minimal unless your solution requires it. Like a disaster recovery solution may use multiple snapshots, but it's constantly creating and destroying, constantly doing that in order to replicate smaller pieces of a VM instead of the much larger piece of a VM. And it can consume a large amount of storage as a result. And, it can have unexpected results when deleted improperly. Although nowadays, there is a lot of capabilities now with the new virtualization platforms. If you are using Hyper-V, maybe you built out on your Windows 11 system, or you have it on Windows Server OS, or you're even, you're even using Azure Stack, which is the next iteration of Hyper-V, of the Hyper-V operating system itself. There's a lot of different options where you can apply it, you can revert it, you can delete snapshots, merge them, rename, export. You can do a lot of different things. I won't really dwell on this, but just know that you have lots of options when it comes to snapshotting that will give you flexibility. So like if you install or you want to make a change in your lab, for example, on a virtual machine, you can make that change, see what it does, and then if it breaks it or it does something funky, you can actually go backwards in time. So that's the benefit really of snapshots. The other thing is I mentioned mobility. And again, recall that VMs are just files. So in Hyper-V world, it's usually like a VHDX. In VMware world, it's VMDKs, and there's others. But they can be copied, moved, deleted, replicated, and if on shared storage, it can be accessed on multiple systems. Because of high availability, before virtualization, if a physical server went down, the application went down. Nowadays, if the physical stayed down, the application stay down. If a physical server went down, the application went down. If physical stayed down, the application stayed down. Now with virtualization, if a physical server goes down, all VMs on it will automatically start back up on something else. And you can, VMware calls it vMotion, Hyper-V calls it live migration, but it's the same idea of while the hardware is up, you can move a virtual machine from one host to another. Perhaps you need to perform maintenance or patch a specific Hyper-V host or a virtualization host, and be able to do that while not interrupting all the applications that are running on that operating system or in that server. We talked about replication. I won't get into that, and other DR solutions. Now, disaster recovery, replication. Now, this is, again, being able to replicate a virtual machine between data centers, between buildings, between cloud and on-premises. And this can happen for numerous reasons, whether it's a natural disaster or man-made disaster. And so let's talk about, a scenario here where really this has actually helped organizations throughout the years. For example, in 2012, there was Hurricane Sandy, and Hurricane Sandy was a really big, massive hurricane that swept through the eastern seaboard of the United States. And it took down quite a bit of data centers. It flooded. There were buildings that were out of commission for weeks on end, with no power. It was flooded. Just really bad hurricane that year. But this is an email that we received back in October of 2012. Specifically talking about, they had just implemented Windows Server 2012, and with Hyper-V, they were able to use Hyper-V to replicate their data center to a different area, a different data center in an area that was not impacted by this hurricane. And so here you see how grateful they were, because with this done, they were able to fail over as a result of this, as a result of this outages. And within, something that would have taken them 2 weeks to get back into business, they were able to quickly continue their daily operations and not impact their business throughout this period because of disaster recovery, virtualization, and, having the right plans and everything else. So, and that's important, right? Because, for a lot of organizations, especially when this hurricane hit, they were down for a long time. And when they're down, that impacts the income, money flow into the businesses. There were some businesses that end up closing as a result of data loss. And even though we're talking about Hurricane Sandy in this case, every single natural disaster that hits a big metropolitan area is going to experience something similar. So nowadays, when you start looking at, okay, who are still the major virtualization players? I would say nowadays, especially, VMware is still an industry leader. Microsoft is second runner-up. But then you have Nutanix, who is, in many instances starting to beat both of those. And with Microsoft really taking a back seat from the standpoint of being on the on-premises data center, but more in being a market leader because it's the operating system of choice in the Azure cloud, right? Which Azure is run by Microsoft. And it's one of the big two, which is AWS and Azure, as the two biggest cloud providers overall. When you start getting on premises, that's still Nutanix. And then there tends to be a lot of other ones, that I won't mention here, but I list them here for just to kind of give you an idea. There's always going to be a flavor for everybody, because it's expanded so much, but something to think about. Now, the reality is that more and more the movement continues to be that the hypervisor, the management, it's now commodity. Management tools are where most of the IT professionals are focusing on, and everything is moving towards those cloud providers, right? And what's made that possible is by thinking now, instead of virtual machines or servers, they're simply resources. And there's this whole movement to be able to create more and more flexible virtual infrastructure, as well as moving up the levels of applications, and what is an application, redefining what that means, and making it easier for organizations to stand up infrastructure really that's someone else's, and instead of buying hardware, they're simply renting it, right? They're not renting the whole server, they're renting just micro capacity of an entire data center. So it's on demand, it's capacity, but it's moving from a capacity based mentality to a consumption based mentality in the IT field. And so this really allows organizations to quickly be flexible. And so cloud by itself is going to be a topic that we're going to be talking about next, because it allows for so much flexibility that it's important for you to just understand how that flexibility impacts businesses, organizations today, and how it continues to kind of redefine what it means to be even an IT professional nowadays. And so next week, or our next session, we're going to be focusing on what is the cloud, and we'll be talking about the different components that make up the cloud, and hopefully this is something that you'll be able to enjoy and catch live. If not, hopefully you'll catch the recording of it as well. So, do you want more? Hopefully you found this session beneficial. And, just a reminder, I'm doing this live every Tuesday at 8 p.m. So I encourage you to come out watch it. If not, catch the recording, right? And if you want to get more free training, and feel free to check out my Facebook group where we're publishing links to all the videos. We're answering technical questions. We're providing additional tips and tricks of different types of technical skills that you might want to add to your technical toolbox. So feel free to check that out. The link is on the screen. As well as, if you want more and more of these videos, check us out on our YouTube channel, as well as our primary website. And if you want to learn how to install VMware Workstation and build 2 Windows 11 virtual machines as part of that, I encourage you to go check out our free Build Your Lab session on our go.experthats.com site /free-build your lab. And that's where I'll walk you through the step-by-step how to log into Broadcom, how to get your free license, how to download the software, install it on your hardware platform, whether that is on Windows or even on Mac, and you can use Fusion, and be able to quickly get up and running, get your lab up and running, and be able to experience all the benefits of that. So feel free to like, subscribe, and leave comments, and I look forward to be able to answer any questions that you continue to have in the comments as well. So thank you very much, everyone. That concludes today's session, and I hope you take care and keep learning.